In programming, variables are named pieces of memory that are used to store values. In Java, we have to specify the type for a variable, and there are two major categories of types, primitive types and object types. These behave somewhat differently, so let's look at an example to illustrate those differences. So in this program here, my first line declares and initializes a value of a primitive type, so int is a whole number. And if I were to kind of represent this visually, I might say that I have a variable named x, so that's a memory location, and that memory location holds the value 12. Now here on the second line, I'm declaring and initializing a variable of type point, which is an object type. So similarly, I have a variable called p, which represents a memory location, but what the memory location holds here is going to be a little bit different. So when I initialize p, I'm making a constructor call, and what this constructor call does is it's going to first create an object somewhere in memory, and I'm just going to represent this by a fuzzy cloud, and then we're going to call the constructor. Well, of course, this object, first of all, has two fields, x and y. And when we call the constructor, we're setting the values for the x and the y field. So x is 12 and y is 3. And then the last thing that happens when I've called the constructor is I've then created this reference over here, and I have set it to refer to the object itself. So what's the reference and what is this arrow here? So again, as I said, the object is kind of stored somewhere in memory, and we want this variable to know where to find the object. And so what's being stored in the memory location p is basically a memory location that tells us where to find the object. And so I'm representing this here by an arrow. You know, it tells us this is where you go and find the object. So now there are implications to this different way of storing these primitive versus object types. Let's say that I declare another int variable called y, and I set that equal to x. And then let's say that I declare another variable of type point, and I set that one equal to p. The behavior here is going to be different. Let's see how our picture gets updated. I'm going to have now a variable called y, and the equal sign, the assignment operator, always takes the value on the right and stores it into the variable on the left. So here I'm evaluating x is 12, and I'm storing that value into the variable on the left. So y is now 12. Let's do the same thing with p1. So p1 is a variable of type point, so it represents a memory location, and I'm setting it equal to p, so I have to evaluate the value on the y and then store it into the variable on the left. So, well, what is p? P is not actually the object here itself. Remember, it's a memory address that tells us where to find, rather tells Java where to find the object. So similarly, we're going to take the value of p and we're going to copy it over to p1. So what that looks like is we're going to copy the memory address, and we're going to get essentially another arrow that tells us where to find that object. All right. So now what happens if I start changing some of these variables? For example, what if I set y to 15, or if I set p1.x to 15? Let's update the picture. So y is going to change, so I'm going to go ahead and remove the old value, which is 12, and I'm going to store the new value, which is 15. So notice that x hasn't changed, right? Once we made a copy of the value of x, x and y are fully independent. When we set y to 15, y now has the value 15, but x again does not change. Now let's look at this next line, p1.x equals 15. Well, p1.x means that I'm dereferencing p1, following this arrow essentially, getting to the x, and I'm changing the value of the x field in here. So I'm going to erase this value and set it to the new value, which is 15. So notice that here, only one value has changed. But if we try to access p.x, p.x is also the new changed value, because p and p1 are both references to the very same object. The distinction between how primitive and object types are stored in memory is particularly important to understand when we have more complex pieces of code that involve methods and parameter passing. So here's such an example. We have a method here called test, and we're going to see what happens when we pass in both primitive types and object types. So I've drawn out again these first two lines that haven't changed from the previous example. We have variables called x and p. And the next line of code is a call on that test method, passing in both x and p. So what happens when I make that call? Well, in the test method, you now get two new variables, one called val1, which is an integer, and this only exists within the scope of test, so basically between the curly braces that define test. So val1 and my point. So I have these two variables here. And when I make the call, test x comma p, the value of x gets copied into val1. So I take the value of x, it's 12, and I copy it into val1. And then I take the value of p and I copy it into my point. So what's the value of p? Well, again, the value at the memory location called p is itself a memory address, or essentially a memory address that tells us where to find the point object itself. So I copy over this memory address so that my point knows where to find the same point. Again, I can represent this by drawing another arrow that references the object. So what happens when I execute the code here? Well, the first line changes val1, so I can go ahead and erase val1's old value and put in the new value, which is now 15. And then the second line changes myPoint.x. So I'm going to follow this arrow, my point, and find my point's x, which is here. I erase the old value, and I replace it with a new value, which is 15. Okay. And so now I want to print out the value of val1 and the value of my point. The value of val1 is going to be 15, and the value of my point is going to be 15.3. Then the test method finishes its execution. I'm back in main. The next line of code asks me again to print x and p. So when I print x, I get 12. And then when I print p, I will get again 15 and 3 because there's only one point object that was ever created. We changed it through a reference called myPoint, but we see that change through the reference called p as well. A nice way to test our understanding here is to look at an example where the names of the variables in main scope are the same as the name of parameters in a method. So here I've drawn out the first two lines here that declare and initialize some variables. I have an age variable of type int, which is a primitive type, and I have a temps variable of type int bracket bracket, which is an array, and that is an object type. So here we can see that the object again is somewhere in memory. It's kind of this fuzzy cloud thing, and temps holds the memory address of that cloud, and so I can represent that by an arrow telling me where to find it. The next line of code tells me to make a call on test, passing in age and temps. So again, this means that down here I'll have variables in test scope. So I have age and I have temps. Again, the names are the same, but don't be confused. These are in different scopes, so they're different variables. So for this first call here, I'm passing an age. That means I'm making a copy of whatever's currently stored in the age variable in main. Great. Here I have the value 1. Then I'm passing in temps. That means I'm making a copy of whatever is held at the memory location called temps in main, and that is a reference to an array. So I can copy that reference by having this arrow here. When I execute the code in the method, I'm adding 1 to age, so I'm erasing what's there, and I'm replacing it by 2, so the old value was 1, now the value is 2. And then I'm saying go to temps at age, so temps at 2, 0, 1, 2, and change that value by adding 2 to it. So it used to be 12, and now it's going to be 14. Next thing I need to do is println age and then the temps array. And I'm just going to type out the output in this comment down here. So I have age, again I'm in test scope, so age is 2, a space, and then the temps array, which is currently 53, 23, 14, 4. This call on test is done, and so that means I actually need to erase these variables. They don't exist anymore at all. And then I can go back to main and execute the next statement, which is another call on println. And this time I'm printing age in main, which is still 1, has not changed since I made a copy of it. And then the value of temps, which has changed because I just made change through another reference, but it was the same object. I only had one array ever, just 2 references to it. Now we do age plus plus. There's only one age variable, it's the one in main, and I'm adding 1 to it, so I get 2 over here. And next call is a call on the test method. So again, I'm creating 2 local variables here, age and temps. And these are my parameters. These are 2 memory locations that I've set, and when I make the call test age temps, I'm copying the value of age in main into age in test, so you get a 2 here, and then similarly I copy the value of temps in main to temps down here. I'm copying this memory address, so I get 2 references again to the same array. I say age equals age plus 1, so locally here to test I change this value from a 2 to a 3, and then I change the value at temps at age, so age is 3, temps at 3, 0, 1, 2, 3, and I'm adding 2 to it, so I had a 4. I change this value now to a 6. To a 6. Great. Now I'm hitting a println statement, and so what do I print? First I start with age, and again I'm looking at age in test scope, so the value of age is 3, and I print the value, I print the contents of the temps array, and so the content of the temps array is now 53, 23, 14, 6. I'm done with this execution of the test method, so that means that these local variables here go away. I can erase them here, so all this stuff goes away. And I'm back in main, where I look for my next statement. So my next statement in main is a call on println, and I'm going to println age, which up here in main is 2. Sorry, I'm going to println 2. And then I'm going to go ahead and println the contents of the temps array, which is 53, 23, 14, 6. Great. Let's double check that we got this right. So I'm going to compile this, and then I'm going to run it. And sure enough, that's exactly right. And so drawing these pictures and making sure we understood what the values of these variables in different scopes were was very helpful.